simply rotate them between classes. So your
Okay.
office hours on Saturday, everyone's going to get that address. And so everyone will come to my office hours. What is it? It's 5:30 to 6:30, I believe.
5:37.
5:30 to 7. Yeah, those are my office hours for all my classes. So again, I have to use a platform, a Zoom to hold the office hours. I don't have a Zoom to just dedicate to office hours. I just have Zoom for classes. That's why. So it's not a class on Saturday. It's just my office hours.
I was concerned. I thought I was missing a class for the whole year. I was like, wow, no wonder I'm so behind.
No, I promise you that's not what's going on. No. How do I get my screen? Oh, new share. I click on that. Okay, we're actually. I sent you as a. People have been wondering what happened to the answers to homework 2, and so instead of just going with more Python, I thought we'd just do the answer to homework 2, and then have a chance to. We could just take the entire class to criticize the answers that I came up with. So that's the announcements for today. Unless if you have Python questions, I'll answer them. If you have Python questions, I'll answer those. If not, we're going to go do the homework 2 solutions. So I sent you the key, and this is what I intended to do during the semester. Unfortunately, we never got here. So we're here now. And again, we'll get those things and see what's what. Okie dokie. I'll get mine up here somewhere, around here someplace. Okay. If you have any Python questions, I'll be happy to answer those. Your test will just cover while loops and for loops, no functions. No functions. Well, maybe functions. I don't know how people feel about functions and lists.
Function is hard.
Functions are hard. Okay, we'll just do up to while loops then. All right, so we got 118 questions, and this is our last day before our final, which I guess is next week sometime. It's in the syllabus. Oh, God, it's in the syllabus somewhere. Let me get out of here. Oh, my God. Excuse me. Syllabus. Let's see. I made this thing out a long time ago, and so I don't remember what's in it. And let's see what we got here. Let's see, when is our final? Oh, wait, there's a schedule somewhere. Oh, here it is, schedule. Semester, yeah. Yeah, when I made this out, I thought we were doing Visual Basic. So that would be Python is on the 3rd. I should change that to Python. It's not going to be Visual Basic tests. We did do everything though, except for control objects. We didn't do that. But compounds, conditions, nested loops, for loops, while loops, for loops, while loops. And you're supposed to have a VB test at the end. This will be a Python test. And the semester ends on the 8th, and the grades are due on the 15th. So I have to have the grades all done. I did forget to do something. I was supposed to calculate all your grades. Okay, I will do that. Tomorrow's Thursday. Okay, I'll get that to you before the final. actually long before the final. I forgot to do it. Okay, so much for so much. Oh, what time on Thursday? Next Wednesday. It's probably, let's see. Let's see. Okay, for night classes, the final is usually the same day the class meets. Well, let's do this. Let me get the file out to you before the club, before next Wednesday, and then I'll get it to you maybe Sunday, and then you can work on it, and then on Wednesday we can discuss it, and if you finish, great. If not, I'll give you a little more time to finish it up. Right, so I'll try to remember to do that too. Okay, onward then. Right, so if no one has any questions, we're going back to those halcyon days of yore back in February and March, when we were doing, before we got to this point. Okay, so here we are. 3D printers print objects designed by CAD software, which is actually true. A bookmark is a copy of a site's URL. That is also true. I've got a bunch of bookmarks on this thing, but I see, okay. A coil attached to a microphone diaphragm generates sound waves as it vibrates. That is false. That is quite false. A compute stick is just another name for a
That's
flash.
false?
I'm sorry.
Why is that false?
Microphones don't generate sound wave. They convert sound waves to electricity.
So doesn't the coil do that though?
The coil converts the sound waves to electricity.
So so it's just in the wording that it's wrong.
A microphone, what is a microphone? You speak into a microphone. I was thinking about the microphones you attach to your computer to record stuff. That's what I was thinking of. You're speaking of a loudspeaker, but okay, I guess that was ambiguous too. But that's the kind of microphone I was thinking of. All right, let me just color that. And if you want to send your stuff again, okay, I'll admit that was ambiguous. Ambiguous. I just want to keep track of these things. Okay, onward. Let's see. A compute stick is just another name for a flash drive. I suppose that was ambiguous too, but a compute stick is actually just a small computer. It's like
I took that one wrong.
well, again, that might be ambiguous also, but just what is a compute stick? They're actually the future of computers. It's just a little CPU and you can attach a lot of stuff to it. What you do use a compute stick for is you can attach microphone, I'm sorry, not microphone, but you can attach speakers and other things to the CPU wirelessly, to the compute stick wirelessly, but you do have to attach your smart television to the compute stick by it attaches to the HDMI port.
Oh, is that like an Amazon like Fire Stick or something? Is that kind of similar?
Unfortunately, I'm not a big Amazon fan. Well, I'm not an Amazon fan. I don't know what Fire Stick is. I've heard of it.
It's like a thing you plug into your TV and then you can, it like gives it makes it kind of like a smart TV.
Well, no, this is a computer.
Oh,
it's
okay.
more than just a smart TV. It has its own memory. You can attach secondary storage to it wirelessly. The only thing you can not attach wireless to a compute stick is your monitor. That's because monitor transfers so much data that it can't do it very quickly through the air. I mean, I guess they could work on it and do it better, but that's what a compute stick was. And if that one, but A computer accesses data in random access memory faster than data on long-term storage devices. That's actually true. That's called the transfer rate. The transfer rate for the number of bytes per second that's transferred from your secondary storage device to memory is in milliseconds, and the transfer rate for memory is for microseconds and nanoseconds. Microsecond is a millionth of a second. Nanosecond is a billionth of a second. It's just so much faster. Transferring stuff in memory from your CPU to memory is just very much faster. Okay. A computer monitor works by pulsing electricity through liquid crystals, which then align themselves to allow light to pass through color filters. That's true. A computer virus can make individual programs fail, but cannot make the computer itself stop working. That's actually quite false. Computers are much better at protecting themselves now from viruses, but certain technological advances have made computers a little bit even more vulnerable. There's something on your computer called a BIOS, a basic input-output system that's used, well, start up your computer. And now that used to be stored on something called read-only memory or ROM chips, but now it's stored in some programmable memory. And viruses can get in there and take control of your computer at that very, very low level. Yeah. Anyway, it's fun.
So you're saying that now they can't do that, or they
now
can
do it. Yes, now you can do it. Let's see.
So they've gotten worse?
Well, it's kind of like a war, and the attack and the protection kind of switch back and forth. Viruses on what is it called? EEPROM. Oh, it doesn't say. Billions of computer viruses on EEPROM. No, these are just antivirus ads. I'd have to look on YouTube to find how virus works. Okay, that's enough of that. Okay, there we go. A computer accesses data in random access memory faster than data on long. We already did that one. That one. Okay, a computer virus. Okay, we did that. Hey, a computer's clock speed measures the number of instructions per second that the computer executes. No, that's actually not true. An instruction often consists of several parts. And what the computer clock measures is how many, a command requires about 4 steps to execute. And what the computer clock does is it synchronizes each of those steps. There's what is it called? Fetch, decode, execute, and store. There's 4 steps the CPU goes through to carry out an instruction. And so the clock, excuse me, the clock synchronizes when how those steps are carried out. So the first beat you fetch, next beat decode. So you're always doing part of that cycle on each clock tick. And so again, when you see something, but it's actually not misleading anymore. It's misleading the other way. Now, because you have multiple core chips, I think they now have 8 core chips coming out. You can execute several instructions on several instructions can execute on each core. So the actual
9?
Go on. I'm sorry.
Is this number 9?
No, that's number 8.
Oh, okay.
We're doing 8. Let's just go through them, and you can tell me if you don't like the answer. A core executes multiple instructions sequentially. True. A device driver is a software program that translates between a specific piece of hardware and a specific operating system. True. A disadvantage of voice internet is that users can encrypt their conversations. False. A domain name identifies a website's host location. True. A file's extension usually indicates the program or programs that can open the file. True. A flatbed scanner creates zeros and ones representations of a document. True. A GPS receiver needs to get signals from 3 satellites to calculate longitude, latitude, and altitude. False.
Is that because it needs 4?
Yes.
All right.
Yes, because it needs 4. A monitor screen resolution is a monitor's width height. A monitor screen resolution is a monitor's width to height proportion. False.
Is that the aspect ratio?
Yes. A network communication protocol is a set of rules that enable network users to exchange messages. True. A noise canceling headphone incorporates a microphone that listens to ambient sounds that are all around the microphone and calculates a sound wave that will cancel it out. That should be cancel them out, but same idea. Yes, that is actually quite true. That's a really brilliant piece of hardware and software. Noise canceling headphones.
I thought that they like vacuumed out your ear because that's how they feel when they go in your ears. They feel like they suck out the sound.
I've never had any. I'll have to buy. Well, they're kind of expensive.
Yeah.
Not going anywhere.
Bose like make some that they have like they have a battery on them, and when you put them in, they like it feels like it's sucking your ears out. Like it doesn't hurt, but it feels like that sensation. It feels like a vacuum.
I'll have to try it. Where were we? That is a very nice invention, though. Okay.
Is that relatively recent?
Well, relatively recent. Yeah, I guess relatively recent. Sure. Oh, okay. A preemptive operating system kernel can usually execute more programs than a non-preemptive operating system kernel in the same amount of time. Yes. A non-preemptive operating system, preemptive operating system simply snatches the CPU away from a program and gives it to another program. With a non-preemptive operating system, sometimes programs wouldn't give up the CPU. So you're able to execute more programs with a preemptive operating system. Because, well, okay, so that one is, I believe, true. Where are we here? Excuse me. A protocol that manages the security of transactions on the internet is a secure sockets layer protocol. Yeah. You should see that. Let me see if I can get something up here. It doesn't say it on that one. It doesn't even say it here. Oh well.
Up on the URL, how it has that little lock. Is that what you mean?
No, I don't know what that means. I mean, no. Usually it'll say HTTPS. Yeah. And for some reason, I guess I don't know.
When you click on if you click on the URL and put the cursor up there, it'll come up.
Thank you.
Well, it usually does. See, like some of the browsers hide that.
Okay, well, mine obviously is hiding it. I'm blocking my camera so you can't see me. Where was I? Okay, so I wasn't able to do that. Okay, a server is a computer that asks another computer for information. That's false. That's a client. Now, a server can, of course, behave as a client as well. But the job of a server is to provide information rather than to request it. That's what you call a server. Of course, it's what you call it. Anyway, where are we here? A sound card isolates the computer's sound processing function from the rest of the computer. Yes. Excuse me. A speaker inverts the motions of two diaphragms, one for high sounds and one for low sounds, in an electric field. Okay, that's actually not true at all. A USB drive, yes, go on.
So, like, I thought what this says is like that it uses like a tweeter and like a big speaker, like because it uses two sounds, like a big one and a little one, high sounds and low sounds. Don't they do that?
Yes, they do, but a speaker does not convert the motion of diaphragms into electrical into electrical.
This is a microphone.
Yes, it's the opposite. Pardon me. Yes, it's the opposite thing. Oh, God. A USB drive uses the same technology as solid state drive, yes. Okay, now this one was kind of hard to make clear, 25. I probably had to write this several times. A user clicking a mouse causes CPU to interact with more, it should be more than one operating system subsystem. Yeah. Okay, that's true. This is probably ambiguous as well. Number 26, a utility program is a type of application software that allows a user to perform maintenance type tasks. A utility program is not considered application software. They're sort of midway between application software and I guess system software. They simply make they make it easier for the user to program the computer user to interact with the operating system. It's considered a utility program, my file manager, rather than an application program. I mean, what is this thing called? File Explorer. So that would be a utility program, and this thing, Internet Navigator, whatever they're calling it now, or Google Chrome would be an application program. The difference isn't really that firm. Let me find a real utility program. This would be a utility program, I guess. Well, let me see. Task Manager is utility program. There we go. And this lets me run low-level operating system command, or this lets me run commands, I should say. So I could type in something. Oh God, java.exe, that's going to crash. Yeah. So this would be a utility, as would be, it'd be utility. Like it's not really that hard. For example, would you think the calculator program, which is around here somewhere, would that be a utility or a application program?
A utility?
Oh, all right. I would think it would be an application program. I really wouldn't fight about it one way or the other.
Which is it?
I don't know. I would call it an application rather than a utility, but then maybe it depends on how often or how frequently you use it. But something like file compress,
It's definitely utility, right?
Definitely utility. Let me see, I have a utility here somewhere. This is utility. This is PC TuneUp Pro, and I use this to get rid of unnecessary files, clean up disk space, see what large files I have, and so on. Or even to remove files. It's a little bit better than the one that comes in Windows sometimes. Anyway, so this would definitely be a utility. Where I can't anything. Go. Go away. I think we might be Crash program now. Well, that's utility. Let's get back to what we're doing. All right, this is not going to go away anytime soon. Boot never skips the post. Actually, there's two kinds of boots, a cold boot and a warm boot. A warm boot does skip the post. The post is called the power on self-test. Where the computer where the program checks, this checks how everything is going before it starts loading the operating system. The post test is, yes, go on.
There's I think your screen's frozen.
Oh, is it?
There's like something in the middle of it.
Yeah, that's my little program I was trying, that's my little utility program I was trying to show you. Let's try another utility program. I can close this. Okay, there we go. There it's gone. A warm boot never skips the post, that's false. A web-based operating system may not need an internet connection to access most of their files. A web-based operating system user may not need an internet connection to access most of its files. Their files. I think I copied this question from somewhere. A webcam is a camera that allows you to see images on your computer or on someone else's computer connected to your computer on a network. True. A website's domain name includes top-level domain. Yes. An API application. Well, API connects a user to a service, a software service. An Ethernet card, an Ethernet card, and a NIC card are different terms for the same thing. Yes. Okay. An operating system, actually, that should be a preemptive operating system, uses interrupts to switch between processes. Yeah, interrupt is simply a hardware thing that simply snatches a CPU away from a program and gives it to something called an interrupt handler. Well, that's not working too well. So let's just move on. Sorry. An operating system device manager determines which programs can and cannot use a particular device. That's actually quite true. An SSD drive is a series of flash memory sticks. Yes. We actually answered that a little bit earlier where we said a flash drive is the same as a solid state drive or use the same technology as a solid state drive. Yes. Binary and hexadecimal numbers are different kinds of numbers. That was an ambiguous one. A number is a number. Binary and hexadecimal numbers are just different representations of numbers. You'd see 17 or 5 is simply, 5 example is the name that describes the number of fingers and things on your hand, on one of your hands. But however you represent it, it's still 5, or whatever you call it, still 5. Anyway, that one people didn't like very much, so that one's true or false. The next one is actually binary and hexadecimal numbers represent the same numbers using different bases. Binary is base 2, hexadecimal is base 16. We use a decimal base 10, and simply everything is, all numbers are, in our number system, everything is represented as powers of 10. So 46 is 3 times 10 squared plus 4 times 10 to the first power plus 6 times 10 to the 0th power. So everything is powers of 10 in our number system, but you can have other number systems. The classical Greeks use 5. The Mayans use 60. I can't understand, but good for them. And everybody else did something else. So on we go. BizRate does not evaluate online commerce sites. That's what BizRate does. Businesses use geolocation to target consumers by their location, yes. Buying software like buying a car or book means you own the software. That's actually not true. If you ever stop to read those licensing things that come when you install new software, those what are those things called? Forgot the other name for them. Anyway, no, you don't own the software. You just have the right to use it. Okay. Capacitive touchscreens use the pressure of your finger to change the flow of electricity inside the touchscreen. That's actually a resistive touchscreen, but this was false. 41. 42. Catfishing is an example of internet harassment. True. This was one that people didn't like. Click and brick stores cannot compete effectively with Amazon. No, I thought that was false. A click and brick store is a combination of a physical presence store with online capabilities, or
Like Walmart.
I'm sorry,
Like Walmart?
like Walmart. Yes. Yeah, those are click and brick stores. Walmart's doing pretty good with Amazon. We could look up their stock prices. Amazon is about $2,300 a share. I don't remember what Walmart is, but you could see what their share price is right now. Okay. Cloud-based data is stored on several network-connected compute hardware devices. Yes. Yes. When you store something on the cloud, it's simultaneously stored on several computers in many, many distant computers that are separated by wide distances. So if one of the places where your data is stored is nuked, you'll still have it someplace else. So there's a lot of redundant data stored out there on the internet. Okay, where was I? Cloud storage is only one aspect of cloud computing. Yes, indeed, it do. They also have cloud-based programs, among other things, so that at some point, if the internet, when internet connections get a lot better, you won't have individual computers. All your programs will be stored in the cloud, and you'll simply exchange data with your cloud connected device. That hasn't happened yet. Okay. Computer virus and computer malware are not two terms of the same kind of software. I kind of like questions like this because it's got a double negative. But anyway, that's actually true.
That's so difficult to understand when you're reading a double negative with false and true statements.
Yeah, that's why I did it. But I only did it a couple of times. I didn't do it very many times. So,
like the cannot compete effectively, and then it's false because it can.
Not you cannot compete. You cannot compete ineffectively. That's even better. Anyway, let's see. So it's true that computer virus and computer malware are not two terms. Oh God. All right, anyway, that's 46. This is another one I got in trouble about. Computers on the same network have the same IP address. And I said false. And someone pointed out that they do have a public, they have two addresses, a public address for their network and a private, another address to select the individual computer on the network. All right. And I think for some reason I put this question up twice. I had questions from several different chapters, so I tried to combine them into just one homework assignment, and so I missed a few duplicate. So 47 and 48 are the same thing. Computers use statistics to learn how to do tasks. I guess you could see computers do that. It's actually the software. Well, I guess the software is the computer too. So yes, they use statistics to learn how to do tasks better. Computers use the binary number system because the transistor, the basic component of all computers, exists in only two states, on or off, or a lot of electricity, a little bit of electricity, high voltage, low voltage, a lot of light, a lot of light, a little bit of light, so on. Yes, yeah. That and the fact that's actually not really true. I mean, I guess originally it was true, but there's some computers were built on other bases and base 2. It's just they were more expensive because you have to have hardware that can detect more than let's see, with base 2, you only have to detect 2 levels of some physical quantity, like a lot of electricity, a little bit of electricity, a lot of magnetism, a little bit of magnetism. If you want to do base 10, you need, for example, or base 5 or something, then you need more sensitive detection equipment, which is more expensive. So that's why they exist in base 2. Not because of the transistor necessarily, just it's more expensive to detect, anyway, more than 2 levels of some quantity. On and off is actually not very expensive. Okay, CPUs, this is actually a rather technical question, and you had to look up GPUs. CPUs are better for machine learning than GPUs. That's actually false. See, GPUs, graphical processing units, are really good at doing several things at the same time. And that's how neural networks work. So GPUs are a lot better than CPUs. Email is a synchronous communications tool. That's false. See, we're having a synchronous communication because we're answering one another back and forth, more or less. I mean, if you asked me a question now and I came back and answered you next week, that would kind of be asynchronous communication. But I kind of respond to your questions in real time rather than several months later. With the email, it doesn't matter when you, I mean, in general, the efficiency of email communication does not depend on how fast you respond to the email. If you wait a couple of years to respond, that might be a problem. But as long as you do it in a few days, it's not too bad. So I'm sorry, email is not synchronous. Every component of your computer needs a fixed amount of power to operate properly. That is actually quite true. I mean, they can operate on a little less or a little more, but they're designed to operate at best. The best way they operate is they need a fixed amount of power to do whatever they're doing. Okay, here we go. GPUs are better for graphic processing than CPUs. That is also quite true. Again, when you draw a screen, see what's happening. Am I supposed to go into this? My screen is being redrawn about 60 times a second. But most of the time, see, they're just areas where the things are mostly the same color. You got huge blocks of white and gray over here. And so GPUs are good at that. Hard drive storage are stable electrical currents. No, they're stable magnetic fields, magnetism. Hard drives are magnetism. Solid state drives are not hard drives. That might be ambiguous also, but what I meant was traditional hard drives, which are magnetism-based. Okay, on we go. Hard drives transfer data to primary storage faster than SRAM transfers data to primary storage. That is actually false. SRAM stands for static RAM. Static RAM is actually very, very fast. I'm not sure how much you want me to explain any of these things, or just want me to go through the answers until you interrupt me. All right, well. All right, HDMI port transferred visual data, but do not transfer audio data. That's not it. That's false. They do both. Hyperthreading doubles the number of physical cores on a CPU. That is actually false. Well, I'm not, forget that. If the CPU instruction cycle were only a one-stage cycle, then pipelining would be unnecessary. Yes, that is quite true. Resist. If you do the file extension, you may never be able to open the file. That one's another one's kind of ambiguous. There are actually websites that you can, if you've got a file and you don't know what the what is it? The extension is you don't know how to open it. You can upload your file to these websites, and they will. I guess May is okay. Yes, they may not be able to help you either. But for the yeah, that's true. You do need the file extension. Somebody told me that on Apple, files don't have extensions. That on Apple,
That's not true.
I'm sorry.
That's not true at all.
Okay, then I'll.
They just might not be visible, but you can make them visible.
All right. Well, fair enough. Maybe it was you. Okay, somebody told me that, and I mentioned that as hearsay since I don't know, not being gifted with an Apple. If you do, okay, if we did that one. Inkjet printers, laser printers, and dot matrix printers use electrical charges to print. That's an example of an and statement. Inkjet printers, laser printers actually do use electrical charges to print, but dot matrix printers do not. Dot matrix printers are impact printers. They actually hit the paper.
Do they use electrical charges to tell the impact printer how to impact?
Another ambiguous question. Well, okay.
Because like without the electric, it wouldn't be able to print.
But I was thinking more in terms of how they form the image, how they form the characters on the page. That's what I was thinking of. But yes, you're quite right. It is your printer is an electrical device. So okay, let's do that one. All right. Instant messaging and texting are synchronous or asynchronous communications tools. Yes. When you text somebody, you expect a response immediately or almost immediately. Same with instant messaging.
Wouldn't that mean that wouldn't that be synchronous? Because that's happening like instantly, right? Because you said email would be asynchronous.
I did indeed say that. Oh God. Okay, so that was wrong. Aha.
Also on page 96 in the technology in action book,
Yes.
it states instant messaging is synchronous.
Okay. Well, then thank goodness he corrected us.
It says both parties need to be participating at the same time, whereas texting is asynchronous.
Oh, really?
To immediately respond to a text once it is received.
Okay, so instant messaging is synchronous.
Instant messaging is synchronous.
Ah, good. Then false is correct because it was saying that both of them have to be. Oh boy. Instant messaging is synchronous and texting is asynchronous.
Correct.
Good. Then that's correct. It's false. See, for an and to say, for the and statement to be true, both components of the and statement have to be true. In this case, one's true, the other is false. So the whole thing is false.
But didn't you originally have it as true?
Aha.
No, it's false.
It is false. Good. Well, good. There we found another wrong answer. Let's get that one in there. Okay. All right. Thank you so much. It's almost impossible to open a file with the correct application without the file's extension. That is true. The operating system, the Windows operating system uses the file extension to figure out which application to use to open your file. All right. So that was 65. Keep your back straight and your eyes on the same level as your computer screen as you work at your computer. True. Okay. Lossy compression is a requirement for programs and documents. No. lossy compression is okay for pictures because you could lose some of the information in a picture and still have more or less the same picture. There's a lot more information in a picture than you can see with your eyes. So you can lose stuff. With a program, if you lose any part of the program, it's not going to work. So you don't want to use lossy compression.
It's lossy.
It's losing stuff, yes. Mac OS has a lower market share than Microsoft Windows because it runs only on expensive Mac computers. I thought people. All right, well, that one, okay. I don't know where I got this from, but I knew I would have some trouble with that one. Macs are more secure from hackers than Windows because Macs are more popular than Windows. That's actually not. That's not why they may or may not be more secure than hackers. It's simply that if you're a hacker or somebody wants to deliver a virus to someone,
You're gonna want to do it to more computers.
Yes.
So you're gonna want to do it to the one that has a higher market share.
Yes.
Increase your
Macs are more popular than Windows. False. Money is money. It makes no difference if you use credit card or debit card to buy things on the internet. That is false. Most browsers can prevent websites from saving cookies on personal computers. That's true. A lot of websites won't let you get onto their websites without saving a cookie, without saving cookies. But let me do a little plug here for this software. This software that I have on my computer, PC TuneUp Pro, I just run that every night and it removes all the cookies from my computer. So if you don't like cookies, you can do that. There's a lot of, I'm sorry.
Why are cookies bad? Cookies sound like a good thing.
Well, no, cookies are okay, but you may not want people to know what, let's say that you murder your wife, for example, or your husband, and you've been looking up websites on how to kill your wife or husband. Those things are stored, those cookies are stored, and some of that other information is stored on your computer. And so when a law enforcement computer forensics expert comes to examine your computer, that person can find out which websites you've been visiting. And so therefore you want to use a little tool like this to hide your tracks.
Would the forensics person even be able to find them still?
You can, no, you can actually, you can erase all traces of websites from your computer. You have to do, there's a way to, you have to delete the file many, many different times before you lose all information about the file. I mean, if you lose information, yes, you can remove all traces from your computer. You just have to be take a little bit more time, but you can manage to get rid of a spouse successfully if that's what you want to do.
It's my goal.
Also, sir.
Yes.
Back on number 61, it was talking about
let me get back there.
You delete a file's extension, you may never be able to open the file.
Yes.
And I think Randy said that they're required for Macs. And actually, in the book on page 190, it states that Mac and Linux operating systems do not require file extensions. They may have them, but this is because the information as the type of the application that the computer should use to open the file is actually stored inside the file itself.
That one I don't know. I do know that
required them, but I knew that they had them.
They have them, but they're not required. So if it's there, you can still, if you have a file that has a deleted extension, you can still open it on a Mac. It's not required, but Macs do have file extensions.
See what? Okay, if you delete a file extension, you may not. Okay, right on Windows, that's true. That and not have. Okay, that's true. I don't know anything about Macs. Very little about Macs.
Well,
Go
frankly,
ahead.
I didn't know much about about the file extension in Macs either. It's just that the book said, and I'm directing your page where it states that you can open a file on a Mac without the file extension, which makes your question on number 61 ambiguous, because if it's in Windows, it's true, and if it's in Mac, it's false.
Okay. Onward. Okie dokie. Where were we? All right. Most computers have more RAM than ROM. RAM is random access memory. ROM is read-only memory. ROM exists on a lot of devices, and it used to be on your BIOS, but BIOS ROM is being replaced. ROM is going away. That's all I can say. Your clock. Let's see. That's CMOS. Yeah, there is some ROM. There's still some ROM on your computer. When you turn off all the power on your computer, it still keeps time when you turn it back on again. That might be going out also, that you might be able to synchronize your clock from the internet. Right now, there's a little battery on, I don't know about Macs again, but there's a little battery on my computer, not on this one, but another computer. And when that battery started to fail, I knew it because my computer wasn't keeping very good time anymore. So I had to have a little battery cut.
Are you talking about like the little watch batteries they have?
It's like a little watch battery, yes.
Yeah.
It is a little, I guess it is a little watch battery. Yes. I don't know about Macs. I'm just talking. Okay. 72. Most people use blogs and wikis to collaborate on projects. True. MP3 is an uncompressed audio file format. False. Multiple core CPUs execute instructions concurrently. That means each CPU, each core on the CPU, you can also have multiple CPU computers, though those are going out of fashion. Anyway, multiple cores, well, that's not true. They're not going out of fashion. Anyway, multiple core CPUs can execute instructions on each core, and they do those concurrently they do that at the same time. Let me go with my cat. If you want to build another digression, I think I have 2 cores on this computer. I'm not sure.
What's the difference between a core and a CPU?
A core can, I mean, a CPU can contain multiple cores. A core, though, is a unit of processing. It's like a,
So does your computer have multiple CPUs or multiple cores?
This one has multiple cores, which I don't seem to be able to show on this thing.
So they're like dual core, quad core, 5 core, 7 core, 8 core?
No, it's, well, 6 core and 8 core. I don't know. I've never heard of 5 core.
And then like, and so that's not the same as a CPU, right? Like a dual core processor doesn't mean it has 2 CPUs. It means it has 2 cores on one CPU.
Yes. Yeah, that's what it means. Multitasking operating systems use interrupts to complete 2 or more tasks at the same time. That's not why they have interrupts. Interrupts are the purpose of an interrupt is to snatch the CPU or away from one, or let's say core, if you like.
Does it like prioritize a task over another?
The operating system does. Yeah, the operating system prioritizes tasks. And if your computer starts to fail or it might snatch the CPU away from whatever program is executing and try to save all your files. Anyway, so yes. No, you don't have to complete the task at the same time. In fact, the interrupt will snatch the core away from a program before the program completes, before the program finishes. When you only had single core CPUs, the interrupts would make it seem that you were executing more than one instruction at the same time. But all it was doing was giving, let's say, 1,000th of a second to one program, and then automatically switch to another program, give it 1,000th of a second, and it would just go around and around and around and around, giving the CPU to each of the programs. Now that you have multiple cores, it does the same thing. It just schedules, the operating system schedules which program gets which core at for which amount of time. But you can literally run lots of programs at the same time. I thought my task manager would let you see that, and I'm not going to go and open it again, so let's just move on. All right. Natural language processing software understands natural languages like English and Spanish in the same way that people understand natural languages. No.
So like, doesn't that? I think I Googled this and I found that it does. It said that it does anyway. Like, cause like, you know how when you like ask Siri how to say, like when you talk to Siri or like Alexa or whatever, they like understand the same way as we understand now. Like they like understand our colloquialisms and like our general speech. Like you don't have to use a specific keywords to make them operate anymore.
Also in the book on page 176, it says that natural language processing is a field of artificial intelligence that uses software to analyze, understand, and generate human languages naturally, enabling the users to communicate with computers as if they were humans.
Yeah, that's like Siri and Alexa.
I strongly disagree with that. They do not understand the emotional content of languages. They wouldn't.
No, it's a technicality.
But sure, if that, I mean, I'm not gonna go against that. They can certainly understand. They can respond properly. If you told a computer to give you a hand, I assume it would, or these natural language processing programs, they wouldn't try to actually give you an actual hand. They understand it to that extent, but I don't think that yell at a computer would get sad. And so part of understanding language is to respond to other people in a way that people should understand. People should respond.
So like the emotional aspects.
Oh,
But
yeah.
aren't there humans that don't understand emotions?
That's true.
That is quite true also, but it's a general statement. That's quite true. So let's just change that and move on. Let's see here. Where's my stupid? Oh, there we go. Okay. Neural networks are so good that it's not necessary to train them to recognize spoken words. That is false. You have to train neural networks. That's actually what they're good for. They just don't come out of the box understanding everything. You got to teach them. Non-power components sometimes keep a computer from going into a lower state. Yeah, that just happens. By lower state means a lower power state.
They're sad.
Yeah, that's actually a poor design, though. A non-power component might be, I don't know. You're talking, and the computer keeps responding to, or at least, responding to your voice, and that would stop it from. a program in a computer goes into a lower power state when nothing's going on. And so if it's just listening to someone talking and that stops it from going into a lower power state, that's a mistake. That's a poor design. I was trying to see how many power states I just have shut down and restart. I have another computer that has sleep and hibernate as well as shut down and restart. So those are all examples of lower power states. Sleep and hibernate are examples of lower power states. And I don't know which is which. In one of them, it simply slows down as it shuts off my hard drive. And another one, it saves everything I have in memory, but it doesn't do anything anymore. And then when the program starts up again, the computer starts up again, it revives all those programs. So those are lower power states. The program is doing less stuff. It stops your hard drive from spinning and a bunch of other stuff. I don't remember what they all are, but you can look them up. And they don't have them on this. I'm on a laptop, and I have a desktop someplace else, and the desktop does have a lower power state, which is good. You want to save power. This one does have if I take out I got my power cord plugged into this thing, I take it out. Yeah, I should be going into power saving mode. Yeah, battery settings. I don't know if you want to see this. It says we found okay, so it goes into power saving mode if I automatically go be less than 50% of power. Well, I do have sleep settings on this. I didn't know that. Oh, on battery power, turn off after 30 minutes. When plugged in, turn after 2 hours. Yeah, I'll just plug it back in. There we go. I know that was exciting. All right, anyway, blah, blah, blah. Non-power, okay, we did that. Non-preemptive scheduling works best for interactive systems with multiple jobs to handle. That's not true at all. A non-preemptive scheduling means that the same program stays in memory for a long, long time. If you have if you have several jobs to handle, you don't want a non-preemptive scheduling. You want to be able to switch back and forth between all those jobs. So that one is false. OCR software can read printed text but cannot recognize handwriting. False. One very important virtual machine limitation is that every virtual computer must run on the same operating system. That's false, but you might wonder what a virtual machine is.
You can like run a Mac. A Mac can run a virtual system. It's Windows.
Yeah. Okay.
Is that like that kind of virtual system?
That would be a virtual machine. Yes. It's simply recreating a machine. It's recreating hardware and software. It's making your hardware pretend that it's software. There's a lot of those out there. A lot of those out there. Unfortunately, I can't remember what one of the best ones is, but let's see.
Virtual machine makes a really good one for Mac.
Okay, good. Open source software costs more than proprietary software. That's false. Open source means that there's no owner, or it's a no owner. So it's open source. They give you the source code. You can modify the source code. There's a lot of organizations out there. The Free Software Foundation, which thinks software should be free, obviously. And open source just means you have the source code. See, there's source code and machine code. The machine code is what's actually executed on your computer. The source code is written by programmers and then translated into machine code. So open source means you have access to the the human readable or human changeable modifiable code statements. Like Python. Now, there you go. Python, we have open source programs in Python. All right, where were we now? We're coming to the end.
83.
83. Operating system software sometimes contain mistakes that operating system updates fix. That's what operating system updates are for, to fix. Optical storage devices transfer data to and from primary storage more quickly than mechanical hard drives. No, that's false. You should look up the transfer rate for DVDs and Blu-ray. But they're not as fast as mechanical hard drives. Plug-and-play architectures require computer technicians to configure particular hardware devices to run on particular operating systems. That's the whole idea of plug-and-play. It means that the hardware knows how to set itself up to run on different operating systems. Sort of misleading, but that's what it does. PowerPoint, Word, and Access are examples of database software. We didn't actually get that far. We did. Yeah, only Access is an example of, no, we didn't. We just, did we get the,
Talked about Access a little bit. We talked about Access a little bit because I asked about it.
Oh, good. Well, very little then. I think we did mostly Word and PowerPoint.
Yeah.
Okay, that would be, real-time operating systems do not dynamically switch between processes. That's true. A real-time operating system is usually dedicated to a particular piece of hardware, like your car. Oh, your car, or a drone. They have to respond. Real-time operating systems have to respond to real-time events. One of the limitations, or one of the requirements for a real-time operating system is that it respond to a real-time event within a certain amount of time. So going back to those robots, if somebody threw a baseball at a robot, it would have to be able to respond to that baseball coming at it. Well, you're a real-time operating system there. If I threw a wrench at your face, you'd have to respond. If you waited for a couple of minutes to respond to that wrench coming at your face, you'd lose a number of teeth. So you have to respond in a fixed amount of time in order to be considered a successful operating system. Okay, well, that took care of that one. RSS is a format that sends the latest blog content automatically, yes. Scanners convert light into electrical signals, yes, again. Simulation programs allow users to experience dangerous situations without risk. I don't know about the take experience, but fine. You have flight simulators. I don't know when you're in a flight simulator and you're actually experiencing a dangerous situation. I don't know how much experience would mean, and I mean, how much experience you get, but certainly better than nothing. Smartphones use geolocation technology to determine their location. That one's ambiguous also. It's the smartphone towers that determine their location.
But the GPS chip within the mobile phone is also what allows them for geolocation to be possible.
Okay.
Like if you didn't have a SIM card, you could still locate your phone.
All right.
No, if your GPS chip is what allows geolocation to actually happen from the towers. It says it on page 116.
Okay. Hold on. All right. Solid state drives transfer data primary storage faster than, mechanical hard drives, and more importantly, cost less for the same amount of storage than mechanical storage. Actually,
They cost
Solid
more.
state drives are more expensive, and their transfer rate is not as, they don't have, mechanical hard drives still transfer stuff faster than solid state drives. What happens now, though, is that a lot of times you'll buy a computer with a solid state drive for your operating system and a mechanical hard drive for most of your data. The reason is that while mechanical hard drives transfer data faster, solid state drives start up faster. When you power on your computer, solid state drives come up faster than, they get started faster. They don't transfer data faster, but they get started faster. And so they put the operating system on the solid state drive to get the operating system into memory as quickly as possible. So a lot of computers now come with both a solid state drive to get the operating system into memory, and because when you have a solid state drive, you turn on that computer and the operating system is in there right away. You don't notice any kind of delay the way you do with operating systems on hard drives. Anyway, so let's see, 92, blah, 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 is false. 93. So, some computer software send messages to game controllers. That's true. I found a lot of this stuff on YouTube. I was anticipating the person who is quoting the book. I was anticipating that people might not get the book. So I found a lot of these answers online, and I didn't check to see if they contradicted our textbook or the textbook, because my goal was to try to avoid having you buy it at all. But okay, fair enough. Some smartphones measure your blood pressure. True. Some web pages do not provide accurate information. Those are true. I mean, in order for that to be false, you'd have to say all web pages provide accurate information. All right, the CPU performs the following actions in order: fetches the instruction from memory, executes the instruction, decodes the results, and stores the results in memory. No, it actually fetches the instruction from memory, then decodes it, then executes it, and so on. The CPU is one of the few important computer components that is not connected to the motherboard. No, it's on the motherboard, whatever the motherboard is. All your components are on the motherboard. Most of them, at least. Where was I? That was 98. That's 97, 98, pardon me. The CPU is one, no, I did that one. The CPU's program counter does not count the number of programs that are executing CPU commands. That is quite true. The program counter contains the address of the next instruction it's about going to execute. So program counter is a little bit misleading, but that's that. Let's see. The difference in speeds between level 1 cache and the CPU cause processing bottlenecks. No, okay, I'm not. Does anyone want to know what cache is?
I would love to know what that is because I got that one wrong.
Oh, okay.
I thought it sounded true and I couldn't find anything online. I tried to a lot of the questions were kind of specific.
Well, no, you can find cache memory.
But I couldn't find the thing about bottleneck.
Okay. Bottleneck is when the CPU is demanding more memory, demanding instructions and data faster than the memory manager can send the memory to it. And that was the case many, many years ago. But now they added cache. In fact, that was the purpose for why cache memory was added to your computer, to your CPU. What cache memory stores instructions. The most frequently executed instructions are stored in cache. Therefore, the CPU, when it requests an instruction, doesn't have to go out to random access memory, which is much slower and less expensive than cache memory, which is actually something called SRAM. Oh God, it's called SRAM. And it's much, much faster, about 10 times faster or 100 times faster than standard memory. So you have these instructions stored in cache. and the CPU, because they're physically attached to the CPU, and so the CPU can get stuff from cache almost instantaneously, where it would take it a long time to get stuff from random access regular memory. There's a lot of software that makes sure, there's a lot of programming, the operating system programming that makes sure that the CPU doesn't have to look very far for its next instruction. And so the most frequently executed instructions are stored in cache. And it's the memory manager's job to keep as much memory as possible as close to the CPU as it can. There's several levels of memory. There's something called virtual memory, which is your hard drive pretending to be random access memory. And the memory manager tries to keep, the idea of modern operating system is to keep as many programs in memory as possible. Now, it can't keep all the program in memory, so just keep some of the program. And if it tries to get an instruction that's not in memory, it has to go out and get the program from the rest of the program from secondary storage. That's in virtual memory. In virtual memory is simply secondary storage, really slow memory, pretending to be random access memory. But a really good memory manager and cache manager or memory manager are trying to keep instructions and data as close to the CPU, as much in cache as it can. And that's really, really hard to do because you have many programs are in memory at the same time, as I will show you right now. It's a complicated story. So I've got something called the Runtime Broker, Microsoft Store, Grove, WSPX, Microsoft Word. Now these things are in memory, but it looks like, my Microsoft Word program is 66.8 megabytes, but I probably don't have all that memory I don't have all the entire program in memory at the same time. There's part of it's actually probably most of it is in in secondary storage in virtual memory because I'm not using Word right now. Here's Zoom meeting. That's taking up it's taking up a lot. Well, it was taking a lot of my CPU time, and let's see. Zoom is taking up a lot of CPU time. Yeah, see, it's power. It's using a lot. Very high memory power usage. But most of this stuff has 0 CPU time, and I'm only using half of my memory right now, of which I guess most of it is taken up by Zoom.
Is that memory? Is that RAM?
Yes, that is RAM. Well, again, let's say it's RAM. Though some of it is duplicated in SRAM or in cache. SRAM is cache.
Cache, the CPU?
No, cache is not the CPU. It's memory that's right next to the CPU. Think of it as distance. So it's very close to the CPU. So it doesn't have a long distance to travel to get to the CPU. So it can be executed very, very quickly. Now, Zoom, for example, since we're using Zoom right now, probably a lot of Zoom is in cache right now. And so I'm executing the same instructions over and over again in Zoom. And so a lot of Zoom is in cache. I'm not doing too well explaining this. But think of it, okay, I guess the best way to think of it is distance. How far is the memory from the CPU? Cache
is the closest, and then the RAM is the second closest, and then the memory is the farthest.
Let me go through that. Cache is okay. Let me go through this. All right, the CPU has on it some built into it about 64 memory locations called registers. That's the closest you can get. That's in the CPU itself. Then you have cache, which is attached to the CPU. It's not the CPU, but it's attached to it, so it's very close. Then right beyond that, and there's at least 3 levels of cache. Level 1 cache, level 2 cache, level 3 cache. and they're all further and further away from the CPU, but still very close to it. Even further still is the random access memory, RAM. Okay, but still very fast though, very, very fast. RAM is fast. And then beyond that is virtual memory, which is your hard drive, your secondary storage that the operating system is making look like memory. So your memory is divided up into pages, little blocks. And so you're not your memory, but your program is divided up into pages. And so it first checks to see if that page is an S. The CPU first checks to see if the page is, well, the memory manager first checks. The CPU says, I want to do this instruction. Here's the address. And the operating system checks. Is that address in SRAM? I mean, in level 1 cache? No, look at level 2 cache. No, look at level 3 cache. Is it in random access memory? No. Okay, now what it does is it switches a block of actual memory, of random access memory on the hard drive on your computer. It switches that with a virtual memory. So it has a complicated set of rules to determine which parts of your program are going to stay in memory and which parts are not going to stay in memory. Besides, so it kicks one block out and moves another block in, and that block, as you use that block, as you use the memory in random access more and more, it drifts into cache. The stuff that part of your program that you most use is in cache. I hope I'm making sense. And as your program uses less and less of those instructions, that instruction will drift from level 1 cache back to 2, back to 3, back to random access memory, and finally back to the hard drive and virtual memory. Does that make sense somewhat?
Kind of.
Kind of. Anyway, that's how it works. It's not that interesting. Unless you're a systems programmer and have to write an operating system, or your operating system not working anymore, you got to figure out what's wrong. I once worked at a place where a little section of memory had gone bad. And if we loaded our programs into memory in the morning, we'd be able to skip that section. But if we ran the program in the afternoon, earlier programs were using the good part of memory, and we loaded our program in the bad part, the program would crash. And it took us a long time to figure out what was wrong. Actually, very long time. But whatever that's worth. Anyway, whatever that's worth, let's go on. Where are we? Is this it? No, this is it. We're okay. Blah, 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 blah. Okay, that's false. I'm sorry?
Bottlenecks is where we're at.
Okay, no, that doesn't cause a bottleneck. Bottlenecks are caused when the CPU is requesting more memory faster than memory. When the CPU is requesting more instructions, is requesting instructions faster than the memory manager can deliver the instructions to it, or instructions and data, excuse me. Faster than the memory manager can deliver the data to it. Modern operating systems cut down a lot on bottlenecks. And the best way, the easiest way to get rid of a bottleneck is to buy more memory for your computer.
Like what kind of memory?
Random access memory. You can't buy RAM. I mean, you can't buy cache memory because that's attached to your CPU. There's got to be random access memory. What is this? Oh, this is 38%. I'm using 38% of the CPU and 51% of memory, which is good for something. Anyway, let's keep moving. That's 100. Okay, we just have 18 more to go. The file manager keeps track of how files are stored, but the memory manager allocates storage for each file when a user has been cleared for access. That's actually false. The memory manager and the file manager cooperate with one another. In copying, when storing files from memory, or storing files in memory, on your secondary storage. So you're copying stuff from primary storage to secondary storage, or from random access memory to your secondary storage device, like your hard drive or whatever. They all are cooperating to get your computer to run. It's a very, okay, anyway. The internet and the World Wide Web are two terms of the same thing. That is false.
What is the difference?
The World Wide Web basically is the GUI part of the internet, the graphical user interface part of the internet. The internet is simply the network that connects all the stuff together, and it has some text qualities to it, but the World Wide Web sits on top of the internet. It uses the internet to transfer data, but the World Wide Web determines what the data looks like. I guess, what is it? Facebook uses part of the World Wide Web, and trying to think of something. I can't think of well, your internet service provider is part of the internet. That's not a really great distinction, but the internet service provider main job is to transfer stuff from one network, one computer on the internet to another computer on the internet.
So like you can the internet allows you to allows your computer to like run things. Like your computer can run software from the internet, and you can like stream things from the internet, but what you're looking at isn't necessarily the World Wide Web. Like you might not be looking at a website, but you'll be using the internet to like transfer data.
If you're looking at if you're looking at a website, that's the World Wide Web.
But like if you're sending an email, you're using the internet, but you're not on the World Wide Web.
No, it's actually, you're accessing your email manager on the World Wide Web. The email manager uses the internet to transfer the email from one website to another.
So the internet is what I get from the internet provider, pretty much.
Yes.
So then everybody uses it wrong.
You get access to the internet.
So we're not getting the internet. We're getting on the World Wide Web.
So the internet is kind of like UPS, and the World Wide Web is the package they deliver.
I guess you could put it that way, yes. And when you open up the package, that's the world. No, UPS is the internet.
Exactly.
Okay.
What they deliver is content, which is what you're saying. The World Wide Web is content.
Yeah, well, you have to open up the package. Yes. Yeah, okay. So you open up the package and you get your television. That would be the World Wide Web. It's you don't use the internet directly. You don't care about the internet. You care about being able to see stuff or watch movies. But the movies are transferred from one website to another by means of the internet. But the stuff for displaying the movie on your computer, that's the job of the World Wide Web. You don't really see the internet anymore. I mean, here, this is the internet. Let me do an internet program here. If I can find one. Let me do this 1 moment. I don't want to digress too much. Okay. So this is going on the internet. Ping. Let me see. British Museum. How does museum? Is that it? All right, some other museum. Oh God, Los Angeles. Let's try this one. I don't know about this. Angeles City College. So what I'm doing.
3 L's.
Oh.
Misspelled angel.
God, let's not go through this.
Angles.
Let's see. That's ping, California.
Google dot.
Google Doc. Okay, google.com. There we go. And so I just sent a message to them over the internet and they responded. This is the internet. Not very good graphics. So
It was like how it was developed whenever the United States government developed it.
yes. Well, yes. This is a little more advanced than when they first came out. But yes, this would be more of this is more of an internet thing than a World Wide Web thing. And so don't ask me what all these things mean. I just did this for illustration purposes and we're done. So that would be the internet. The World Wide Web sits on top of the internet. The World Wide Web can't function without the internet. The internet can function quite well without the World Wide Web. The internet was developed. Okay, so I'm going to go on there. The internet and the World Wide Web are two terms for the same thing, that being false. The internet was designed to be resistant to disruption by enemy attack. That's actually true. The internet is.
I have a question.
Sure.
Was the World Wide Web designed that way also, or no?
It's designed to make money.
So it wasn't designed to be resistant to disruption by enemy attack?
Well, no, because that's not its job. The internet doesn't have, it doesn't do communication. It does visualization.
So it's prone to enemy disruption.
No, it's not, because it sits on top of the internet.
So it's resistant to disruption by enemy attack.
This is what the purpose was.
It's not either?
Let me explain a little better. Perhaps it's not getting. See, let's suppose that you were talking to somebody in New York on the telephone, and then suddenly Chicago, and your telephone call was being routed. This is a landline, of course. Was being routed through, or it doesn't matter, being routed through Chicago. And so suddenly Chicago has been nuked. So there's no more Chicago. But you only lose communication for just a couple of seconds because the internet is smart enough to say, well, there's no more Chicago. Let me go through Austin, Texas, and then through Atlanta, Georgia, and then up the coast to New York. So it's smart enough to find a different communications route. That's what the internet does. The World Wide Web has nothing to do about that. It has nothing to do with the World Wide Web. The World Wide Web uses the internet to exchange, to send data and receive data. Okay, that's the best I can do. And you're saying, was the World Wide Web designed to be resistant to it? It doesn't have to. What you're saying about the World Wide Web doesn't do communication. That's the job of the internet. It doesn't transfer data. That's the job of the internet. So they didn't have to design the World Wide Web to be resistant to disruption by enemy attack. Because it uses the internet, it is resistant to disruption by enemy attack.
I get what you're saying. Okay.
Okay, all right. 103. The most efficient memory managers run more programs at the same time than less efficient memory managers. This is an and one. And also use less data than less efficient memory managers. That's false because a memory manager's job is to cram as many programs as possible into memory. So it's going to use more memory than less efficient memory managers. It's going to run more programs and use more memory than less efficient memory managers. That's 103. They run more programs, true, but they don't use less memory. They use more memory. They use as much memory as they can. Use if they can, use every byte of memory, every byte of memory that they can use. And going back to my little my task manager, let's see. I'm not really using a lot of stuff. I'm only using 50% of my memory. because I'm not doing a lot of stuff, and only 40% of my CPU because I'm not doing anything. If I was playing a game though, like Halo or something, I don't know if people play Halo anymore. If I was playing a game, I'd be using a lot more memory, is what I'm trying to say. But I don't really play a lot of those games anymore. Okay, so that was 103. The network manager is one of the 4 essential operating system managers. No, that's just something you have to look up. The
What
operating,
are the 4 essential operating system managers? Because I looked it up and I couldn't find anything.
no, there's not. It's not that I just made it up.
There aren't 4 essential operating system managers?
Oh, there are, but the network manager isn't one of them.
Well, what are they? What are the 4 essential operating system managers?
Excuse me, the memory manager, secondary storage manager, memory manager, file manager, device manager, and the memory manager, device manager. I can't think of the 4th one. Memory manager, device manager, memory manager, device manager.
Network manager?
No, it's not. Thank you so much.
You're welcome.
Device manager, memory manager, secondary storage manager, and I guess the CPU manager. I'm. Oh God, I forgot. There's 4 of them, but I can't remember what they all are. But I guess it has to something has to manage the CPU. So I guess it's something's managing the CPU. And the network is the network is a device. You have a network interface card or a wireless interface card, and that's managed by the device manager. They all work together to make your computer do all those wonderful things.
The internet says that it's a process manager, memory
Process manager. Oh, sorry, I didn't interrupt.
This manager, and input-output system management.
Okay, great. I knew the process manager was input-output is your secondary storage devices. Fine.
I correct myself. The World Wide Web says this, not the internet.
Uh-huh.
That's sarcasm?
Yes.
Oh, okay. Good for you. I couldn't remember process manager for the life of me. Okay. At any rate, where are we? Okay. Okay, 105. The operating system and the computer hardware form a complete system to determine what your system can do. Yes. Yes. Okay, what your system can do. Okay. Yeah, I guess so. It's true. All right. The post office, this is one we're going to fight about. The post office around the world did not provide social networking service before there was an internet. Yes, that's social networking. You send letters to people. That's social networking. Well, you had letters, by the way, mail before you had telephone.
Postcards are like a Facebook post.
Say that again?
Postcards are like Facebook posts.
Yes. Yes.
So I think I got this one wrong. I'm not sure, but I think I got it wrong because the did not. And I agree with the statement that post offices create social networking before there was an internet, but I think the not might have been like what threw me off.
Your downfall.
Yes. I'm not quite sure what I got, if I missed that one or not. Wait, are you going through them so we can go through our assignment and see which ones we got wrong?
Yes.
Oh my God.
Some people are upset because I had not given out the answers to this homework for a long time. And I didn't do that because people were still, one of the reasons I didn't do it was people were still handing in their homework too.
Are you able to, the ones you marked, can you send those ones can you send those ones so I can check mine whenever I'm done? And
Yes.
so, because I have to email you and tell you which ones that I didn't get right or whatever.
Yes, you're going to do that. So I'm going to send this to you. I'm going to make this another announcement. I'm going to save this, make it an announcement, and then we can regrade everything.
Do I have to resend the ones that I got right on the first assignment too? Or
No,
did you already mark it down?
just say which ones were gated by mistake.
Did
What
I,
wrong?
so I sent that to you before. Do I do it again?
Apparently I lost it or forgot about it. I don't know where it is. Just do it
Okay.
again. Okay. Let's see, where are we now? The process manager. God. Oh my God. All right, that was 106. Oh yeah, this is the UNEFI. Those are going to replace BIOSes. The BIOS is prone to error and attack. And no. No, this is 107 is false. I don't remember what the initials of this thing are. Let's look that up. UNEFI. And when you get it, if you're going to buy a new computer, ask them if they will supply this. Let's see if we can get some sense out of this. What? United Nations, that's not what it is. Here, let's try. Excuse me. Computer term. Okay, Unified Extensible Firmware Interface. It's eventually supposed to replace BIOSes and so on. It's a little bit smarter. It's the first program that runs when the computer is turned on. At any rate. Okay, so that one is, so I did that again so you would look it up and see what it was. So UNEFI certainly doesn't wake up the BIOS, it's going to replace the BIOS. You're not going to have both of these on your computers. Okay, the use of hashtags and posts to raise awareness about specific causes, one aspect of digital activism, yes. All right, this is another hard one that was meant to be unpleasant. Unless you defragment your hard drive, you can access the newest files on your computer more quickly than you access the oldest files. First of all, what does it mean to defragment your hard drive? When you first start installing stuff on your computer, on your hard drive, the files are, all the stuff in one file are right next to one another on the hard drive. They're all in the same block. As you put more and more stuff on your computer, a file might exist spread out all over your hard drive. So the longer you use your computer, the more your files become fragmented. Fragmented in the sense that the file is not in one location on your hard drive. It's spread out in different locations on the hard drive. It's broken up into pieces. The pieces are linked to one another, of course. That's one of the jobs of the file manager, but they're still not in one place. So it makes it hard. That makes reading the contents of your file is slower, because the hard drive has to go out and look for the rest of the different pieces of your file. That means that the newest files you read, the newest files that you put on your computer, you access more slowly than the older files, which are more compact. The oldest files were installed before you had a lot of stuff on your computer, and therefore they're all in one place. The newer files generally don't have enough room to put a big file all in one place, so it's got to spread the big file out over to different parts of your computer. So newer files are less compact and you can access them more slowly than the older files. Now, when you defragment your hard drive, you bring all those pieces together, and so you make the files more contiguous. Each file, the files are no longer spread out over your computer. I could actually, let me see if I don't know if my hard drive is, Is anyone unfamiliar with the term defragmenting your hard, what defragmenting means? You don't want to see me defragment my hard drive.
It takes a long time.
It does indeed take a long time. I wasn't going to do the whole thing.
I have a question. Do you can't, there's no, I know Windows and you can do that. There's a utility, but
Yeah.
there's not one for Macs.
Maybe they have a better operating system. Let's see. You probably could, maybe they don't come with a Macintosh. Maybe they, let's see. File, oopsie. File defragmentation Macs. How do you defragment a Mac? Can you defragment a Mac? Oh, you can. Okay. And why you don't, how to defrag a Mac and why you don't need to. All right, so let us not go further into that abyss. Let's go back and finish these things. Where was I? Okay, that was 109, that's false. 110, VoIP protocols transmit telephone calls over the internet. That's what they are. Yes, true. 111, we will see a fully functional semantic web in the near future. I got a lot of flack on that one because near was not, I didn't define what near feature meant. So that might be, that's another one that has to be, well, actually, I probably didn't take off. I marked that true or false, so I accepted any answer for that. Web-based email, to be based with a D. Web-based email and client-based email, install the email management software on the email client's computer. That's another one of those ands. Client-based email does install the software on your computer, but web-based email does not. So that was one of those things I threw up there to be unpleasant. That's 112. 113, webcast and podcast are two terms to the same form of digital media. No. Where are we here?
So like if the ones that you're accepting either answer for, do we email you about those specific questions or?
No, well, no, those when I graded your work, I accepted either answer.
But like about the ones today that we're like, that you marked in red?
Those are the ones that we did that I got wrong.
Oh, okay.
So yes, the ones I marked in red are the ones you're interested in, not the ones that have true or false. Those ones I caught myself. Okay. Okay. This one you could have researched. The person who's reading the book, what does it say about Wikipedia as a good source for research papers? Because wikis are publicly edited.
Yeah, Wikipedia is not good for research papers.
That is true. Good.
Anybody can add information or edit the information.
Correct. Good. This is one I liked. You need special 3D glasses to see the output of 3D printers properly. I don't know if anybody missed that, but that's false. So I don't know. Oh, that's right. I did go to a movie that needed 3D glasses quite recently. I believe it was one of the Star Wars. You should always use complete sentences to describe search targets to search engines. No. Search engines don't really use complete sentences. What they use is keywords. And so what they'll do is they'll find web pages that contain those keywords, and they'll return those web pages to you. And there's different search engines have different criteria for keywords. You can say that you want all these keywords to appear in the web page, or you can say I want this word to appear, but not this one. And so there's really complicated criteria you can set up for searches, but they don't understand English yet. That was 117. You should consider a website's authority when you evaluate its suitability for research. Yes, there are websites that will tell you if other websites are suitable for research. And last but not least, you uninstall software by deleting the software's main file. That is not true, and don't do it. Usually software contains many different files. A program rather contains many different files, and you do not want to delete just one of them. I think I showed you on my PC tune-up thing that it has, where is it? It's up here. It has a thing for me to uninstall programs. Windows, if I can get up to it quickly enough, has an uninstaller somewhere. Let's see, it's in here somewhere. Devices, phone, account, apps. And so I should have updating apps, uninstalling apps. I can come in here and get rid of all the software on my computer, which I'm not going to do. And let's close that up. And let's close that up too, and so on. So that was it.
I have a question. May you, or could you please go through the first couple pages so I could just really quick see which ones were read?
Okay.
So 1 or 3, 4. 3.
3 and 4.
Okay. And 61, 62, 63.
And 67.
And 67.
76.
76.
91.
91.
And that was it.
Okay. And didn't we say 111 or no?
Let's see. We will see a fully functioning. Oh yeah, no, that one. See, I already caught that myself when I was grading them. But you can check to see if you got 111 wrong. Let's just be on the safe side, and we'll mark it if you wish.
And did you and you sent us our files that have the ones that we missed, right?
Yeah, well, no, when I graded them, I didn't say which one. No, when I graded your work, I simply said how many you missed. I didn't say which ones you missed.
Okay.
Which would not really be a good idea for a true and false problem. No.
Now, like now that we are going through them, do I just how do we let you know which ones to go over?
You can send me an email saying we go over these.
Okay. Sounds good.
Okay, other questions? So it's okay, then let's go on to more exciting stuff or less exciting stuff. Okay, I did not do what I said I would do with a Python GUI. I was grading stuff. I've been grading stuff or preparing. I didn't get to it. It's actually there. It's called let's see. Let's just look up. If you don't have any questions about that, I'm going to go back to Python for a moment. Or if you want, we can stop at this point. And there's Python GUI program. It's called tkinter. And it's actually kind of nice. Let's see if I can see some examples of tkinter for you. No, I was looking for books on it. I just didn't think I didn't understand it well enough to try to explain it. So I did not want to really do anything with it. All right. Is this another book? No, pardon me. This is probably just another website for teaching people how to learn Python. Let's see, they want to try to sell you something. Yeah, Python basic books, shrink books, and so on. What website is this? Oh, realpython.com. And I think there must be a python.com out there. Python, yeah, python.org. Yes. So this is the one that I'm using. And I see Python. And this is where if you wanted to learn more about Python GUI, this is where I went to try to figure out how to do stuff. And yeah, here's graphical user interfaces in Python. And it's actually not telling us anything. Well, not at least what we want. Okay. Let's see, I think it's called tkinter. I think that's correct. Okay, well, no, that's not it, I'm sure. No. All right, I just don't have the name right. It's something like that. But we're done with Python. Yay. For a while at least. Let's see, Python GUI, Python. Oh, there it is. tkinter. tkinter. Let's see. Let me try a small. Like I said, I gave up on this because I knew I wouldn't be able to do anything good. Well, let's stop. I'm stopping. So we can stop early. I think that's about everything. Does anyone have any questions? And we can just call it a night.
I have a question.
Yes.
The grades that are on our Canvas.
That's right. Yes. Go on.
In our Canvas profile, are those our grades? Or you mentioned that you had to prepare our grades.
Yes, I was actually supposed to do that before tonight. Yes, I have to download all your grades, and then I have to. I think I have some old grade books I can show you. But in fact, no, your grade will probably higher than what you see on whatever this thing is.
Canvas.
Canvas. So I'm going to try to find this is an old grade book. Let's see, this is, wow, this is really old. Okay, let's see if I have a grade book in this one. I just hesitate to do it. It takes me a couple of hours to prepare it, and so I don't do it. But this is what happens if this ever comes up. And so this is in, is this the final grade book? Yeah, this is the final grade book. Well, to walk you through the process, and you can see that you will not be mistreated by it. So Excel, which we don't think we covered very much. All right, so there we go. Thank you so much. So this is the original data that I download from Canvas. So this is the original data. So this is what I download. I must have edited somewhat though. Oh no, I didn't. See, this is how the thing appears on Canvas. So I take that data, I edit it somewhat, getting somewhat nice. Well, I edit it a little bit. I hide everybody's name, and then I have this stuff. So this is your classwork, and so I simply add up all your classwork, and I normalize it so everything is within from 0 to 100. Let's see, this person's total points was 79.5, but when I normalize it, it's 82.8 because the maximum number of points is 96. So when you normalize it, with a scale of 100, 0 to 100, you get a little more points. So this person had 93 points total, but when you normalize, you get 97.7. So you do the same thing with the homework and the same things with the tests, and you come here to your grade. So in this case, the test weight was 40%, the homework weight is 50%, and the classwork weight was 10%. And so you calculate your normal weight. Let's see if you can see that expression up there. Let's see if I can move this. There. You can see that the grade is G2 is your test grade times the test weight plus H2 times the homework weight plus I2 times the classwork weight. And so that's going to all add up to 100. And this is now made. Oh, I see what I did. I hid something. There we go. I'm still hidden. Okay. Unhide. And it's just a field with now. Oh, I just deleted something.
Maybe double click on it.
Yeah, on the top section.
No. I've hidden columns D and E, and oh God, that's embarrassing. Column width, unhide. Nope. Column width. That's 4.5. Oh God. Well, that's. Oh God. All right. Okay. So I forgot how to do that. How do you unhide columns? Help.
Because if it's hidden, you can't find it to click on it.
Yeah. So there's a way of doing this. Just unhide columns. Well, I think I did unhide it. Unhide columns. There we go. How to unhide a column. Go to Home and select Format Visibility. Go to Home. Format. Oh, Jesus. Go to Home and select Format Visibility. Hide and unhide a sheet. So this is Home. That's my Home ribbon. So where's Format? Oh, this must be Format over here. No? Oh, God.
This
Well,
isn't a very good help section.
Yeah. Yeah. Well, fortunately.
Because the ribbon that you're looking for is not there. It doesn't say format anywhere.
Yeah, well, it might be that this is sort of out of date.
Format is under where it says cells. So keep going to your right.
Right.
A little more.
Yeah, there it is.
One of us are just not doing too well, are we? Hide and unhide. Unhide columns. Okay. I already did that.
Like there's no A or D.
No, there's an A.
Oh, there it is.
Oh, right. Thank you, whoever said that. Embarrassed again. Anyway, so you have two grades. This is what I wanted to show you. You have a relative grade and absolute grade. And so the absolute grade is usually harsher than the relative grade. The relative grade is calculated by how far you are from the average, rather than an absolute 90, 100 to 90 is an A, and so on. So the relative grade is usually higher than the absolute grade, and you get the higher of the two grades. So this guy, a major loon, Let's see. So this guy, Christiana Minsach, was getting a C as the absolute grade, got a B for the relative grade, got a B in the course.
So like what I noticed is there's no like people that get B's for the absolute grade and then get an A for the relative grade. It mostly helps you if you have a lower grade.
Get you the higher grade.
But like it looks like it only really helps you if you have like a C or below. Because like
No.
there's no B's that took you to A's.
Well, that's just in this particular example.
Oh, okay.
I mean, this is just one class. Here you had a person who was getting an F and got a C. I'm not sure what happened on that one. Let me try. Maybe I deleted something. Yeah, that deleted something there. This person got an F and got an F, F, and F. So this is just 13% overall, or 13 out of 100. So got an F. This person was 56 out of 100, was getting an F on the absolute grade, got a C on the relative. Anyway, the point of this is that the grade that you see in Canvas, I'm not sure if I even weighted those. Let's go and look at that. Let me see if I weighted them.
I think you might have, because I remember asking about it one time because I was like, why is a test only worth 10 points, but my homework was worth 40? And and I think you corrected it that day. My grade went up a lot.
Let's see. Let's see. Grades. I think. Well, no, it's not there. Oh, let's not do that. Okay. All right. So we want not. It's not. Does it want grades or no assignments? Sorry. So we can see what the weights are here. Yeah, I did weight them. So it's 20% for classwork, 40% for homework, and 40% for tests. That's it. Okay. And so what I do, but those are your absolute grades that you're looking at. So I have to download these. I have to calculate the relative grades, and I believe the grades are due on the 15th. Let's see, what is the 15th? Yeah, the grades are due on the 15th. So I will have your stuff. I'll create the grade book. I'll also create a grade book tonight. I'll try to create a grade book tonight. I just don't like to create more than one. I like to do it when the semester ends because it takes a while to do it. And oh, let me go back to that grade book.
So there's if we have an A as our absolute grade, there's no possibility of us getting a B.
No, it's not. You see,
Okay.
it only works to make your grade higher. You get the higher of the two grades. If you got an A as an absolute grade and an F as a relative grade, your grade would be A. That's so no, it doesn't work against you. It only works for you. Why am I doing? Oh, I did want to show you one thing. Visual Basic. Ta-da! I use Visual Basic to calculate your grades. There's a function. Abs grade by points is double. Da-da, dim grade is string. If points are greater than 90, grade equal A, else greater equal 80. You should be able to understand this from Python. You should understand this from Python. So this is how I calculate your absolute grade. And your relative grade is simply your distance from your average. So I have an average here and something called a deviation. And if you're 2 or so, okay. So that's Visual Basic. For those of you who are really wanting to see Visual Basic, here is something like Visual Basic. It's actually Visual VBA, Visual Basic for applications, but it's close enough. But so at long last, love, there's Visual Basic. Well, that's what I'm going to use these two functions. These are functions, by the way. As you can see, they're functions. I'm going to use these functions to calculate your grade. And by the way, this thing doesn't care about how you align everything, so I can just align stuff. You don't have to line everything up the way you do in Python. It just looks nicer. But this still will work. I don't know why Python did that. It makes their compiler easier to write, I suppose, or their interpreter easier to write. Easier. Anyway, so that is that. That's all I can tell you at this moment. I'm going to finish grading all the stuff I have to grade right now. And I have 2 other classes to prepare for. And then I'll get back to you. See, let's see, what do I have to grade? I have 1 from your class. And I got 3 more. Well, there's 3 from your class. Let's see what else is on here. And what else we've got? 1 more from your class. So I'll grade all your class stuff right now. And I'll have to prepare for some other classes on Friday and Saturday, and then I can get to your grade books on Sunday. But I'll have your grade books before your final. And I was wondering if people were going to ask me about your final. Okay. I will give you programs that have logic errors where the program runs but doesn't produce the output it's supposed to produce. And you have to go and read the program carefully to see why it's not doing what it's supposed to do. I will remove some pieces from an already written program. From a program, and you have to supply the missing pieces to make the program do what it's supposed to do. That might be enough. I don't want to ask you to write any complete programs or even, fill in the missing pieces and fix the logic errors in a program. So you get at least 2. You'll get 2 problems like that. And I might give you a program that is supposed to do something, and I'll give you several pieces that you can plug into the program to make it do what it's supposed to do, but only one of the pieces will actually work. And I might give you a program. That's about it. Those 3 kinds of programs. I could give you a program that I think that does not run. It has an interpreter error, interpreter error. It's got one of those it's got the output is in those red messages because it's got something wrong with the indentation or something's missing. You have to just apply the missing pieces or take out the bad stuff and put in the good stuff. That'll be your test. You have 2 hours. If I gave you 4 problems, you'd have a half an hour for each problem. Any other questions?
Can you repeat what you just said about the test?
Okay. 1.
About how it's going to be like you have to fix something, or
I'm going to tell you exactly. I'm going to do it again. I'm going to say it one more time.
I apologize. I really want to be clear on what I have to. I've been watching videos.
Okay, here we go. I will give you a program that does not compile, does not interpret. It has an error. Some of the errors we got were we didn't indent things correctly, or just the syntax, the grammar of the program is bad, and so the program doesn't like it. For example, I could give you a while loop that doesn't have a colon at the far right of the while statement. I might spell else-if wrong. I might type ELSEIF, something like that, and then you have to fix it.
Okay.
That's one kind of error. Another thing, the program runs, it does stuff, but it doesn't do what it's supposed to do. I'll give you a description of the problem. This is what the program is supposed to do, but it does something else, and you have to fix that. So you have a logic called a logic error.
Okay.
So you have interpreter errors, logic errors. Interpreter errors, the program doesn't run at all. Logic errors, the program runs but doesn't do what it's supposed to do.
So like the program doesn't do what the directions say to do, but it does something.
Yes.
Okay.
That would be a logic error. Then I would give you, there's a part missing from the program. There's a piece missing from the program. So it runs, but it doesn't give the correct output. It's like a logic error. Logic error, So everything is there. It's just everything that's there is not what's supposed to be there. In the kind of program I just mentioned, they're just part of the code is missing. And
So like an if statement or
an if statement might be missing, part of an if statement. Let's say you had a multi-branched if statement. Remember if, elif, elif, and one of those elifs might be gone. Or one of the conditions might be gone in a condition, in an if statement. The condition might be missing. And you look at what the program's supposed to do and try to see what it actually does do and figure out what's missing. Okay, finally, a whole chunk of code is missing. Just this obvious stuff is missing, and I give you four or several other chunks, and you're supposed to plug those chunks in to get the thing to work the way it's supposed to. Now, all the chunks that I give you will make the program work, but only one of them will make it work the way it's supposed to. So those are the four kinds of programs, four kinds of problems on your test.
and they'll be like all four?
Yes, you've got a half an hour for each problem. Your test is 2 hours.
And it's timed?
No, it won't go away if you do it. No, it won't disappear if you don't finish within 2 hours. But you do have to finish within limits. We'll think about. Let's see how the test goes. We'll see what happens. Well, we'll discuss it some more. But no, I don't know. I don't know how to give a test in Canvas. I'm sure it's possible, but I only know how to give tests that start and end at certain times. I think quizzes can be let's see. I think quizzes. Let's see. I just don't feel like calling it a quiz. Let's see. Let's look for a quiz. Quizzes. Excuse me. Add a quiz. It says quiz instructions, shuffle answers, multiple choices, required access code, filtered IP address.
Time limit, it's up higher. It's right.
Time limit. Well, yeah, I won't do that to you.
Thanks.
But I thought I could also make them start at different times. But I don't see that here. At any rate, I wasn't going to do this to you anyway, so it doesn't matter. Let's go back to this thing. No, I might just I'll give you extra time just to make sure you get through it. Yes, go on.
This is going to be next week during our class time, next Wednesday.
Well, I think the test is actually supposed to be from 8 to 10. I'd have to look up the exact schedule for it. They give us the final times. I don't think that they've either published it yet. Maybe they haven't published it yet, or I haven't seen it. But my policy is just, since everybody's been able to meet from 6:50 to 10, why not just start the test at 6:50 and then go on till 10, and that'll be that. But the final is supposed to be 2 hours.
Okay.
But we'll just start at 6:50 and stop at 10 o'clock and hope everyone is finished by then. And we'll see what happens at 10 o'clock if we're going to get more time. Okay, other questions? Okay, so now I hope I can remember how to see what I did. The reason I hid those columns is because I sent the grade book to people, and there's a feature on in Excel that will prevent people from changing in the settings. And so when I hid the columns, the people weren't be able to, get them back again so they could see everybody's name. So I hid the name column as well. And that's why I did that. And I didn't remember how to undo it. but thank you. I'll try to remember how to undo that from now on. Okay, so that's it. Some people were upset because we didn't do Visual Basic, and
Yeah, it's me.
that's you. Well, if you want to send me your old Visual Basic programs, if that's the person who said he had old Visual Basic programs, I can grade those instead of Python.
I sent you actually. I emailed you.
Oh, email me to to Canvas? To here? What is your name? Oh, that's okay.
I sent you my homework things.
Oh, well, I know I got your homeworks. I've graded, as I said, I've graded almost everything you guys sent me. I only have 4 things to grade. But on the Visual Basic stuff that you sent, I'd like to grade that. Did you send it to this? Did you send it to Canvas email?
No, I sent it to your school email from my email actually, not from
Send
here.
it to Canvas email. Please.
Okay, I'll do that.
I'm actually. Oh, God. Oh my God. Okay. So. Do you want to shut down now? Do you have any more questions?
Actually, I wanted to go through my homework 9 with you if it's possible.
Okay, homework 9.
Yeah, I did it, but I have problem with functions, so I did it simple. It does the same thing almost. So yes, if it's okay, I can share my screen with you and you can check it out.
Okay, let's see what this is. This is shift encryption. Okay, let's. But if you share your screen with me, you're going to share your screen with everyone.
That's okay. I don't mind.
And those of us who can leave early, can we go ahead and leave, or do you want us to stick?
I just have to know who you are so I can punish you effectively. No, of course you can go. I don't really. I'm running out of things to say. Well, if you want to go, go. I have nothing more to say that I think will help you. I've discussed everything I could think of to discuss. So, bye. You can send me
Thank you.
You're welcome. You can send me your whatever your questions or objections to any of the grading in the in the homework 1 and homework 2 stuff. And just any questions you have is fine.
Thank you so much. Have a good night.
Thank you. Thank you very much.
Thank you. Have a good night.
Live long and prosper.
I'm gonna stay and watch you explain the other thing to that other person.
Yes, sure. That's how we works.
You have to give me permission to share my screen.
Oh, okay. Sorry. You're
Okay.
right. Just one moment. That's here. Okay. You should have it now.
Yeah. Give me 1 second, please. I don't know why I cannot share it for some reason. Let me see.
Let me see if I actually gave it to you. No, I'm sharing screens. They aren't hidden, just scrunched. Okay, I didn't know.
I don't know why I cannot share my screen for some reason. It doesn't show me the program I wanna share. Or I can send it to Canvas and you can open it. I mean,
Okay,
then it'll be easy to work on it.
okay, let's do that then.
All right.
I'll grab the screen back again. And here's all our lovely faces. All right, well, while we're waiting, okay.
I send it.
And there it be. Good. All right. I think it went in here. No. Maybe this is it. Oh, that is it. Okay, let's open her up. All right. It says text. All right. Text comma integer equals input, enter a string. Text equals text dot replace. I'm not sure, what is the purpose of these replace statements? Let's run it and see what happens. Enter a string with comma followed by space. Hello, comma, space. Is that what I'm supposed to enter?
Yeah, with any integer you wanted to change the position of the letters, the alphabet.
Okay, well that's all right.
So like hello and then cipher that 1 or 2.
You maybe put 2 in there, yeah.
Well, hello, comma 2.
Yeah. And now you may want to put negative integer as well. It's gonna work just backward. Let's say hello, comma -2 or 4 or 5 or whatever number.
G, E, that seems to work. And oh yeah, that's working. That's working. But you didn't want to create a function.
I to be honest, I have a hard time creating functions.
Okay, It says key equals integer, alphabet equals ciphertext, positive. Brian text, position equals alphabet dot. Okay, well, it works. It's rather clever. I didn't really see that.
Yeah, even if you first time run it and add negative integer, it's still gonna work. It works either way. So
Yes, let's see. So we have text equals text dot replace. So we're replacing the comma space with simply an empty string. And replace space, comma, just a space with an empty string. So you're getting rid of the commas and the spaces, and you're just gluing everything together. And so then he says for I in text, position alphabet equals find I. Okay, new position equals position plus key modulo 26. Ciphertext positive plus equals alphabet new position. Okay, that's working. That's working. All right, so you do, yeah. All right, well, it works. As you said, there's no functions here. But, all right.
but the only thing it has problem with, if you just simply type any string without any number, it's not gonna convert it to anything at all, because you're not giving it any position to replace the letters with.
Well, that's an error. Let's see. What? Well, see, you might want to check to see if integer, before you convert integer before you convert integer to the key, you might check to see if integer actually exists, because it's a string right now. You could check to see if integer's length is 0.
Well, 0 works because it's not gonna change the position of the letters. It's just gonna print the same thing.
No, I said if it's an empty string, if integer's length is 0, if there's nothing there. You said if you don't type anything in, you can test for that. You were saying that you run the program, you type hello, and then you hit the enter key, and the program crashes.
Yes, but what do we have to change the letters with? You know, it's easy to put that in there as well, but do I have to just choose a position for, let's say, change it to two letters
Yes,
position or something?
you have to. Well, of course, if you don't type a number in, then you have to choose some number so that they won't crash.
Okay, that's easy. Yeah, that's easy.
Yes. Okay, well, that's that.
Yep.
That is that. So you got here. Oh God. Okay. Let's see. Where are you doing the inscription here? Oh, all right, so you calculate. Okay, use the key to add and subtract stuff. Okay, great. Great. All right, well, but it would be good if you could try to use a function for this.
Yeah, I tried the function. I couldn't do it.
But you start off with def and you say what your two parameters are. What are your two parameters? The text and the key.
Okay, yeah. I tried it, but for some reason, whenever I return something, it gives me a hard time that return is not in the right position, and when I keep changing the position, it's still not working.
Well, honestly, you're not trying to return a position, you're trying to return the string. Ciphertext.
It wasn't working for some reason. I don't know.
Yes. Well, why don't you try it and send me the ones that are not working? I can tell you what's wrong.
Let me check if I still have that.
Okay. Well, even if you don't have it, you can try again and send it to me.
Sure, I'll do that.
Okay. All right, but this worked. This is fine. This is fine. This is okay. This is okay. Okay, I'm gonna close this up, and we shall. Did upload this? If whether you get it with a function or not, just upload this to Canvas.
Okay, I'll do that.
All right, so that took care of that question for the moment. Other questions?
I have a question.
Yes.
That assignment, was that assignment like more complicated than what we're gonna find on our exam?
Yes, because you won't have any functions on your exam, so it'll be somewhat easier.
Like, and now, so I have the question. So, what part of that homework assignment is the part like where you have to decide like how to do it? Because like I know like how to do a basic function, but like when it comes to that, I had no clue like where to start. Like, will I just learn that as I go with programming?
Yes. Yes. On that particular problem, yes, I mean, yes, you get more and more complicated programs, and as you do more and more complicated programs, you understand more complicated programs. These programs have been relatively easy up to the encryption and the sentence generator.
The sentence generator I thought was pretty cool. I like that. I didn't think that was bad. But the shift encrypt one was really hard because I had no clue about this ASCII thing. I didn't know about that at all.
Yes. Well, we'll just stick to numbers on the final then.
Well, what do you mean? Numbers?
Arithmetic.
Oh, I like the words. The words were amazing. That was that was like my favorite assignment. But I didn't understand the shift encrypt because I didn't know that ASCII, I didn't know there was two different numbers. And I would never have known that. Like, I guess I wouldn't have known even to look it up.
I'll think of something that's just going to be loops, no files, and I'll try to think of something you can do with letters. You could always, well, I was thinking you could translate something from English to a word from English to Pig Latin.
Oh, yeah, that would be cool.
Well, it involves, of course, moving letters around. You have to remove something from the front, like pig would be igpe. So you'd have to remove the P from the front of the word and then attach it to the N and add AY to it.
So you would have to take position 0 to position to the last position.
Right.
Is that you can't do that?
Yeah, you can copy it, sure.
So you can copy position 0 to the last position.
Mm-hmm. The problem
What was that?
You have to use a substring function to remove the first letter.
Substring function to remove the first letter. So I'm lost now. So is that like what's a substring function? Is that like the remove dot, or is that what that is?
Yeah, let's see. We had it in one of our classwork assignments. Let's look it up though. It allows you to pick just part of the string. Python substring function. It's right here.
I was like watching some videos on Python and they use different terminology. They called like built-in general functions, and then they said function methods or something like that. They called them methods.
We haven't done classes yet. So classes have methods, and then their free functions that are not part of classes are just called functions. A method is a function that belongs to a class. We haven't done classes. That's all I can tell you about that.
So substring is index if a sub. What is a subs?
How do I get a substring of a string? A substring is part of a string,
Oh,
and it has a
so
start.
like in pig, p is part of the string. Is a substring of the string?
Yes, it's a one-letter substring.
Huh. Okay.
Let's see. Excuse me. How do I get a substring from Python? What you want to do is remove it. Okay, let's see. Substring string.
So 2 to the end is what that one was.
2 to the n?
Yeah, that the last page you were just on showed a thing that said 2:n.
Oh, yeah, that was from 2.
So this would be my string, and then parentheses or brackets would be like 0, 1.
Let's look at it carefully. I can't see it. Let's see what they have here.
It's up on the first one.
Okay, this one right here. So that simply gets, I guess that chops off the last. So x is equal to hello, and 2 : is simply the substring from position 2 on to the end of the string.
So to do the beginning, you would do 0, or you can leave. I found out in the video you can leave it blank and put a colon, and it'll do it. It'll automatically default from 0, then to 1, and then it excludes the 1, right? So then that would how you would do. It would be like pig bracket 0, 1,
Okay.
right? And that would give you p.
I don't know. Well, I guess I don't know this version of substring. But this says, so you have hello world. Okay, let's see. You have x equals hello world. X 2 : is everything from 2 to the end of the string. But x 2 simply
Is everything from the beginning to 2.
no, probably gives you the first 2 characters.
Yeah, it's from 0 to 2.
Okay. And minus 2 hello world, I guess, gives you the last 2 characters of the string
Yep.
without. Yeah, there's the last 2 characters. And then you have x 2 : -2. That's me up. Oh my God. Oh, I see. It gives you everything from. It
2 to
chops off
-2.
the last 2 and the last 2 and the last 2 and the first 2 are chopped off.
Yeah.
Is what that does.
And so like would we concatenate then AY on, so you would like find the substring with this, so it would be like substring of X would be :1, and then you concatenate, you make that a new string, and then you concatenate the, no, I don't know, because how would like you have to make it would, so when you find the substring, it doesn't change the original string.
Yes, you're going to make a copy of the original string, though. You can always assign the copy back to the original string.
But then, like, you don't. Oh, okay. So you're gonna make a copy after you take off the first part.
Well, you taking off the first part, you'd assign that to the copy. So you want to get rid of the first letter.
And then, but so you want to get rid of the first letter, and then you want to add that to the end, and then add AY.
Yes.
So like, how do you? So when you find the first letter, how do you get rid of it? Like, how do you make the string that string minus the first letter?
By assigning. Look, let me show you. Let me make sure there's another. I just want to see how this works, and then I'll show you exactly what it is. So this takes off the first letter. Okay. All right, well, let's see what we got. All right, I'll try to remember how to do this and you can help me. Let's get us a Python program up here. And so I'll just get rid of this gentleman's work for the moment. And we'll see if we can do this substring thing. So we'll just start off with, let's just start off with hello. Word equals hello. And let's see, we'll put first equals word colon or colon 1 or 1 colon. We'll figure it out. I'll just print first. We'll see what we got.
And then it'll print H.
I didn't print anything there. Is not defined. Okay, I got you. Oh, because I don't have the quotes in there. Ha ha ha. All right, let's see what we got here. Rather nice syntax, though. I'll give it to them there. All right, somebody did not do this right again.
Why did you add zeros?
That was an accident.
Oh.
I'm actually sitting in a dark room and it's hard to see the keyboard.
Oh. My bad.
Okay, there we go. Now let's see what we got. All right, it says, end of line scanning. Oh, that's because that quote is there. All right, one more time. Okay, we got the first letter. So that's how you get the first letter. And now we just do, now we can take, say, word equals, and now we want.
Oh, we want 1 to end.
Okay, so then will this give me everything but the first letter if I put it on this side?
Exactly.
Okay, so let's print that again. Print word.
And then so we want to add first.
Oh, what am I doing wrong now?
Word equals word. You have to put word in front of that?
Right. Okay, I got a phone call. 1 second. It's an idiot. Sorry, just someone I don't want to talk to. All right, we're cooking with gasoline.
And so now we want to add first to, we want to concatenate first onto the end of word and add, and then concatenate AY, right?
Well, yes, we say word equals. All right, I forgot what the concatenation operator is. It's word
Plus
first plus quote AY. And now I'll print word again. Print word. All right, hello, hello, hey. Hello, hey. Sounds Hawaiian.
it does. So it worked.
And that's how you would do it then. I know, but see, the problem there is you have to, do we want to, I don't want to have somebody learn something during the test. So it wouldn't really be fair to do this. So I wouldn't give you this on your test.
What do you mean? Like this specific way to do substrings? What's the other way that we learned how to do it?
I thought it was with the word substring. Let's see. I thought there was a Python command called substring, but maybe that was just wishful thinking on my part. Let's see, Python substring.
I don't remember that at all. But then again, I'm not always there, like in the head.
It's all right. I'm not, okay, well, maybe we never did. I don't know. But whatever it is, I could not give you new stuff. Yes, but just this is what it is. Slicing using start index and end index. All right, so this is start index and end index. I got it. And so if you leave off start index, it gives you 0. If it leaves off end index, it gives you the end of the string.
Yeah.
Okay.
So we didn't go over this.
I'm pretty sure we didn't. I would certainly remember this. It's
I
actually,
don't remember either.
it's very neat. So maybe they don't have a substring function. I was just,
Well, that's good because I didn't know how to do the substring function. I knew how to do this function, but I didn't know how to do that.
right. Well, I don't think we can do this. I can't do this to people. I have to think of something. But I'm we never did very well. We didn't really do very much string manipulation. We just did the things in the arrays with the random sentence generator. Let's see. Here they are. And we looked at each other. We looked at the individual elements in a string, but I don't think we try to take a string apart. And that might be what I did not, what I skipped. Not what I'm sure that's what I did skip. Let's see. And I think we've only been on strings for 2 weeks. We don't have a lot of string stuff in here.
String was the easiest stuff, though, I feel like.
Oh, well. And we should have started on strings rather than numbers.
So will the stuff be kind of like what we did when we were doing weight and things like that? Because like that stuff I understood. The calories and the cookies and the...
Yeah.
That's comforting because like once I got to the shift encrypt, I started thinking, I don't know anything. But I guess now that we've done the shift encrypt, I probably couldn't do it again if you told me to do it again, but I could maybe do it again with a little bit of time if you told me to do it. I like get all the concepts that are there. I just don't know how to put them into action myself.
So we did count vowels and we did count words with functions and files. But,
see, but we did those things and we didn't do any homework on them. But
no.
like we just like for me personally, seeing you do it in class does very little for me. But doing it myself does something. Like but after we started getting to the point where it was like the last thing, it was very difficult to do on my own. So I don't think I really learned as much. But like the stuff we did at the beginning where it was like write a program that takes this calories and does that, that stuff was like a little bit more easy and understanding. And like the things you taught us in class, like how to turn it into an integer, that stuff really sunk in. But like when we were doing the vowels and stuff, I don't really remember we did a homework assignment that taught us how to count vowels. But it taught us how to like, I thought what you were going to make us do was like make a sentence that if it had a vowel, you had to use the article "an" instead of "a" or something like that. Because just before that, we were doing sentences.
Well, I was wondering if that would be, I'm not sure. I probably didn't know how to get to the first, how would you get the first letter? Okay, well, yeah, you could do that. Yeah, you
It
can
would be
find
an
out what
if
the
statement.
first letter is. Well, we could do that then. But I think it would be better just to go back to simple calculations.
Yeah, I agree. I'll pray.
Because we didn't do, if the string manipulation is kind of vague to you right now, I'm sure you wouldn't want to see it on a test. This was count words with functions, count words, count vowels with if statements. Yeah, let's see here. Yeah, so all I did was go through the individual letters. of
And
the-
sometimes I still get kind of confused on the return because I watched a video and it described the return a little differently. Like it didn't like the thing is I know that you had to put return, but I don't ever know what word to put after return, like return what? Like I don't know what to call it.
It depends. Well, it depends on the kind of function you're writing.
So like if it were a function that adds two things together, you put return sum.
Yes.
But if it were a function that multiplies, return product.
Yes.
But now what if it's a function that encrypts something? Return encrypt, or that would be the name of the function in shift encrypt.
Well, you return the letter. You return the string that you encrypted.
So return string.
Yes.
Oh, okay.
Yeah, that would be. Yeah, you would return the string. Yes, it depends on what you're writing the function to do. If you're adding numbers together, we return a number. If you're, reversing the letters in a string, then you return the reverse string. That's what it does. Okay.
Can we are we still able to meet with you during office hours this week?
Yes, so we'll have office hours till the end of finals. I have another office hour on Friday. Oh yeah, you noticed that. We have an office hour on Friday or Saturday. Well, I have office hour on Friday.
5:30 to 7
Yeah,
Saturday.
yeah, Friday. Should be Friday.
Oh, on my canvas it says Saturday.
Then it's Saturday. Yeah, there should be. I'd have to go. Yeah, if yours is Saturday, then I have another. I did the Friday for another class, and I have to send you the log on information for that class.
Yeah, it's Saturday 5:30 p.m. to 7 p.m.
Yeah, so I believe I have office hours on Friday from 3:30 to 6.
3:30 to 6.
Yes.
Okay then. I appreciate all your help.
Okay.
Have a nice day or a nice night.
All right. Any other questions after this gentleman goes? Okay. Other questions? Other observations?
Is it possible to get an extra credit homework?
No. No, I can't do extra credit. That's sort of a bottomless pit. Just finish the homework that I gave you is still due. You can still turn all the homework in.
They're still open, all of them?
Yes, I believe they all are. Yes. I'm pretty sure they all are. Let's see. Courses. If they're not, I'll open them all. Well, no, the ones that we did since April are all open. The ones in the other part of the class should be closed by now. I think everything we did before April is closed. All the homework after April is still open. Let's see. Okay, so that's homework. Okay, so yeah, homework 2 is closed, but homework 3, 4, 5, 6, 7, 8. That says June 3rd. I'll change that to the 7th. But they're all open until the 7th, except for these guys, which are closed. Okay, that's homework 8. I'll open that until the 7th as well. But yes, all the homework is open. All the homework we did in Python is still open. Yeah, that was closed on the day of the final. I don't know why I did that. And so that's homework 8. Excuse me. Homework 8, homework 8, homework 7, homework 8. All right, so I wonder why I made all those the 3rd. That's strange. All right. Where's that thing? And save this one. And I think this is it. We're coming to this last one. And this is 9. I'm sure I do the same thing.
Professor,
Yes.
sorry if you've answered this already, but is our final grade going to be a part of our test grade, or is that going to be separate?
That's going to be part of your test grade.
Okay.
Yes. Yeah, that'll be your second test. All right, other questions? Well, again, I can't think of anything else to say. I guess the only thing we can do is strings. We can actually join strings together and take strings apart, I believe. What I could do is write functions that do the taking apart for you, and you could just use the functions rather than having to write them yourselves. I think that's doable. And because you use functions all the time in the class, and so just one more function is just another function to use. I think we could get away with that. We could do Mad Libs. I think people might find that interesting. Same thing with the Pig Latin. Yeah, with the, what is that? Not Pig Latin. Yeah, Pig Latin. You don't have to know how to do the substrings yourself. I can simply give you functions that will remove a certain number of characters from the beginning of the string and add a string to the end of the string. And you could just use those functions. You wouldn't have to write them yourselves. You could say, here, this function will do this for you, and you just use it. Because you have used other functions in Python. You might be uncomfortable writing the functions, but it's certainly not a problem to use them. So I think that's what I'll do to get around those little errors, I suppose. Other questions? Okay, we're coming up on the witching hour. I'm sorry, I cannot think of anything else to talk about. See, you could write a substring function. Let's suppose that you didn't really like the syntax with these things. So you write def substring. So this will be a function substring. I don't know if I can spell it right. There we go. Substring as str colon start comma finish.
So we could use this function to do what we just did.
Yes, I was about to do that, in fact.
Oh, okay.
So let's, well, we'll see if I can do it. So that would probably be return str. Now there's got to be some error checking, of course. Str start colon finish. Now I probably have these backwards, or but let's just see. I don't know how to do this myself. I mean, I don't know the substring function. Let's move these guys out of the way. Let's cut this. We'll just delete these. So there's my function. We can just test to see how the thing is supposed to work. I can do print. Oopsie, sorry. Print substring, quote, hello, quote, 2, 4. All right, let's see what we get on that one. Let's hope we don't get any errors. That'll be fun. We get LL. So let's see what we just did. We got hello. So the L starts at 2. That's 0, 1, 2, 3. And the 4 would be the first character outside that range. All right. So let's do this slightly different. Let's say I want the characters between 2 and 3. So what I would do then is I would do this, and I put +1. +1. Because what I want is I want the characters at between 2. I want the second and third character. So it's gonna, that's probably okay. So let's see what that does. We should get the same result. Yeah, we got the same result. But though I would do something like that and just write little functions for you to use to accomplish the task at hand, to create a thing. So let's see, how would you could write a function, you could write a function called remove first. We'd have, what function do we need? Remove first, add, called pop. So pop would remove a character from the first part of the string, and append would add a string to the end of the string. So we just need pop and append. Or if you don't like to write too much, pop and app. Or pop, add, okay, so, and rim for remove. We don't want to type a lot. So rim first, and add last. Let's put first all away. That's really all we need. Remove first and add last. And so remove removes the first letter of the string. Now we could put some parameters there to indicate how many letters it removes. And then add last would add something to the end of the string. Or maybe end, add beginning, rim, beg for beginning, and add end. Add in and remove beg. Rim beg and add rim end. And so that we could do that, we could write those functions, and you could use those to build your Pig Latin strings. Now, Pig Latin has a lot of interesting rules. If you're trying to remove a vowel, I mean, if you want to do owl, let me see, what is it? You just add AY. You leave the vowel at the beginning. So auto in Pig Latin would be autoe. And blotto would be lottobe. So yeah, so you'd have to be able to do those, follow those rules to do your Pig Latining stuff.
I did not know those rules.
It's the language, Pig Latin.
Yeah, I didn't know that was a rule.
Well, maybe, okay, that might be, let's look it up. Let's look it up. Pig Latin grammar. All right, so here we go. So to speak Pig Latin with a consonant cluster from the start of this word to the end of the word. When words begin with a vowel, simply add yay, way, or a to the end instead. These are the basic rules, which are pretty simple. It can take a bit of practice to get used to them. How to speak Pig Latin. Okay, so ultimate yay, Pig Latin is ig, pay, atten, lay. Ig, pay, atten, lay. What would Python be? Yithon pay?
Yes.
But wait. It says move the consonant cluster. So you add all the consonants at the beginning of the word.
Well, see, but is y is a consonant?
All right. So that would be.
So thon pay. That's not right.
Oh,
It's
yeah.
icon pay.
Cluster. So it's Python. It would be on Python.
That's not correct. I've never heard. There is no way that's right. The internet has it wrong.
Well, you can make up your own rules. What is Python? Let's find a Python online Pig Latin translator. All right.
Because like most kids can do this, and if that's the rule, I didn't know how to do it as a kid apparently.
Enter the English text here. Oh no, I did that again. Where's my delete key? All right, here we are. So I'll do Python. The Python, we'll just write Python. Python. One moment. Python. Python. Translate.
Exactly.
Okay, so it said Y was. It said, well, in this case, it said Y was a vowel.
But why is it the beginning of it?
Because it just takes all the consonants until it gets to a vowel.
Well, it just takes off the first. I was under the impression that the rule is take off the first letter and add it to the end and add a Y.
Let's try it. Okay, maybe. Let's try another one. Let's try something that obviously has prattle. Okay, now I say that should be attle pray.
Yeah, I agree. Or rattle pay.
Well, okay, that's the question. Is it going to be rattle pay or addle pray? It's addle pray.
Okay.
So it makes it a little more complicated. It's going to take off the consonant cluster. It's going to keep going until it finds a vowel.
So I guess it counts Y as a vowel.
Sometimes. Let's try pygmy. All right. Okay, that should be
Igme pay?
Yigme pay. Yeah, Yigme. I don't know how are you going to pronounce the Y at the beginning, but let's try it. And that's Yigme pay. Yes.
Okay.
So
what about apple?
That apple?
Yeah.
I don't know. Apple. Apple yay? Apple way. Okay. Let's try way. And that would be I way.
Hey, yeah. What about what's that?
Let's try I way. Let's try.
What about yak?
Yat?
Yak, like the
yeah.
animal?
Yak, don't talk back. Close enough. That would be ack-yay. Let's think of yay. I want yay. Let's see. Y-A. How can we get yay yay?
Y-A, yay, Y-A-Y.
Okay, wait. Yeah, that no, that would okay. Okay, I think Y-A-Y.
Yeah.
Okay. Gee whiz, I've suddenly become animated. That's aye. It took the Y off. Oh, okay. No, that does consonant clusters. Let's see, Y-Y-A-Y. But I think it's just going to move the two Y's to the end.
Yeah.
Yay. I got yay. That was pretty good. Yay. I think that was what I was trying for. Yeah, I think I was trying for yay. How did it do that? It took off the Y. Oh, it took off the first Y
Left the other Y.
and left the other Y. Those are some strange rules. Oh well. This is Pig Latin. I'll have to look up the Pig Latin rules. Oh, wow. Well, all right. So we'll think about that and do some string manipulation. But if we do, I'll give you the functions and you just use the functions. So that's fair enough. Okay, so that took care of that. So now we know how to speak Pig Latin. That's always great. Always good. No, I don't want to say anything. All right, so it is now 10:06. Any questions then? How many people are still with us? 6. Only one person is decamped since we began our Pig Latin search. All right, so I'm for calling it a night if no one has any questions.
Okay, have a nice day.
Okay. If no one has any questions, we will go. So you are the only one whose microphone is unmuted. So, okie dokie. All right, then I'm going to log off if no one has any questions for me. And I will, tomorrow's Thursday, oh God. All right, so I'm leaving here. And we'll discuss the final at greater length. So again, if you have no questions, if you have questions, now's the time to ask them. I'm quite happy to answer them, even though I took, yes.
I resubmitted some of my homeworks and just the last one that I shared with you.
Yes.
Just submitted all those ones.
Well, okay, I haven't got any new homework from you yet. All right, so this is homework 9, problem 1.
No, I submitted through the Canvas. I didn't send you anything. I'll send you the visual